This video tutorial from exocad shows you how to use the Virtual Waxup, Virtual Gingiva, Cutback Library, and Multi-Level Cutback feature. These four new features are demonstrated on one single demo sample called Screw-Retained Implant Bridge with Virtual Gingiva Design. Starting with exocad version 2016, for some restoration types, there are new options available. Let's have a look at the Reduced Waxup restoration type. For all Waxup restoration types, you will find the new drop-down field, Scan Waxup. When choosing Yes, you have to scan a Waxup or import a Waxup scan as usual. Selecting the option No, Design Waxup digitally, results in a different workflow where you design a virtual Waxup first. Furthermore, you will find another new drop-down field for all Waxup and crowned restoration types called Virtual Gingiva Design Mode. You can choose between three different options. No means that a virtual gingiva can only be designed in expert mode. The default mode, Optional, means that you will be prompted in the wizard to decide. Mandatory means that the gingiva design dialog will appear automatically. Let's choose Optional, as this allows us to make this decision later. The same options are also available for Pontics. Please note that you can design one virtual gingiva for the whole restoration, or separate gingivas for single teeth. Separate gingivas on single teeth can only be designed in expert mode by selecting the tooth first. Let's proceed with the design. If not required, you can skip the emergence profile step and proceed to the next step, which is the tooth placement. Make sure that you use the correct tooth library. Only exocad's generic library includes the cutback libraries. Why not use the chain mode for the tooth placement? You will find more information about the chain mode in a separate video tutorial. It is a very nice tool to design full arch setups. To save time, let's do a quick setup by using the chain mode. It might not look perfect, but as the chain mode is not the subject of this tutorial, perfect tooth placement is not important. Certainly you know that very often on these kind of implant restorations, the implants are situated between two teeth. You can see this right here. Well, that's a perfect case for the Virtual Waxup feature. It supports all kinds of designs, no matter the implant positions. Proceed to the next step. We can skip the Generate Abutment Bottom step too, as we did not define any emergence profile border at the beginning. In the first free-forming step, there is one important thing to know in case you decide later to use one of the cutback libraries. If you pull parts from the anatomical tooth or if you add material, this change will not be applied to the cutback design later. On the contrary, removing material or pushing parts into the design is possible and will be applied to the cutback design. This will become more clear later in this tutorial when you see the result. Just keep in mind that we have added material on tooth 16 and removed material on tooth 26. You can adapt the Pontics to the gingiva and the approximal contacts, but if you choose to do a virtual Waxup, that is not really essential, as approximal intersections will be deleted automatically, and the basal area on the entire virtual Waxup will be adapted to the gingiva later. Now you are prompted if you'd like to do a gingiva design or not. That's because we have selected Optional in the Dental DB at the beginning. Let's start without gingiva, just to demonstrate only the Virtual Waxup feature. I will show the virtual gingiva later in this tutorial. Proceed to the shrinking step. Starting with exocad version 2016, there are two new features available in the shrinking dialog: the Cutback Design Library and Multi-Level Cutback feature. In this first sample case, I'd like to start with the Multi-Level Cutback feature. Let's play with it a little. Choose, for example, a low value for the shrinking depth and choose 25% less shrink on the lingual side to the anteriors. Click Apply to start shrinking with the selected parameters. The multi-level cutback feature will thus allow us to shrink again the shrunk restoration with an unlimited number of shrinking operations. This opens up a multitude of new ways to design a reduced restoration. Here you can see that the anteriors have only been shrunk very slightly on the lingual side. This helps us to keep the core shape of the anteriors. Now we could, for example, perform an additional global shrinking with a value of 0.5 millimeters on the entire tooth. To do this, define your parameters for the second operation. Click Multi-Level Cutback and check Reshrink Reduced Shape. Then click Apply to start the additional operation. The advantage here is that the second shrinking operation will smooth the area between the less shrunk lingual side and the buccal side. As I already mentioned, this opens up many ways in the shrinking step, and certainly every user will find their own different ways and other reasons to use it. You could even choose Exclude Selected Parts and mark areas to be excluded from a first, second, or third shrinking operation. Before we proceed to the next step, I'd like to show you the advanced parameters. Here you can change the minimum thickness. Changing the bottom shrink depth allows you to specify a different shrink depth for the bottom. Proceed to the next step. The second freeforming step allows you to freeform the reduced parts, or to adapt the restoration to the antagonist, the gingiva, and the adjacent teeth. The freeforming step will be explained in detail in a separate video tutorial. To save time, we skip this step as a perfect design is not the subject of this tutorial. The next step is the connectors step. This step will be explained in a separate video tutorial, so I'll just make some small adjustments on the connectors. This is not how I'm used to doing a design, but it's a perfect example to demonstrate that the virtual Waxup supports any kind of design, especially between tooth 22 and 23. The software generates a virtual Waxup no matter how the design looks and where the implants are situated, or where pontics and reduced crowns have been defined in the Dental DB. Note that this step may take some time, as several operations need to be computed. Once the virtual Waxup base has been generated, you can click Next to proceed. In this freeforming step, you can perform freeforming as you are used to doing on merged restorations, where smoothing and melting in the areas between elements is possible too. Proceed to the last step. Which is the screw hole design. By default, the screw holes are activated and snapped to the anatomy. Certainly you can switch them off, but keeping them activated might be an advantage, as with the freedom in virtual Waxup, you can possibly create very thin areas around the screw holes. You can decide where you want the screw holes to be snapped to, either to the anatomy or to the framework. The framework option provides at least a certain protection against sharp and thin edges, as it can be used to create a minimum border thickness around the screw holes. Let's finish and have a look at the result. Here you can see how the screw hole design creates a nice border around the screw holes. Difficult implant positions between teeth are no problem for the software. Let's go back and have a look at the virtual Gingiva and the Cutback libraries. Let's restart the same case in the dialog where you are prompted to decide if you'd like to do a Gingiva. This time, we will choose to do a virtual Gingiva. You can change the gingiva's bottom properties. Offset creates a gap between the jaw scan and the gingiva bottom. Smoothing fills out edgy cavities. Milling diameter adds a tool radius compensation for the tool used to mill the gingiva area. If the checkbox Include Gingiva Scan is activated, the additional scan will be included in blocking out. If it is not checked, only the jaw scan will be blocked out. Before you start blocking out, you can choose an insertion direction, which is by default the average of the different implant angulations. On cement retained restorations, it is by default the insertion direction of the bridge crowns. You can also set the view parallel to the insertion direction. Set the insertion from view. To verify, set the view from the insertion direction. Then click Apply to start blocking out. The light blue mesh displays the blocked out surface. You can still change the parameters and apply again by clicking Update. You can also clear and reset the settings. Use freeforming if you desire to manually block out certain areas. Here you can add and remove material as you are used to doing it in freeforming. Note that removing material is only possible on blocked out undercuts and might recreate undercuts. The depth of the undercuts will be visualized with a color scale. When you are done, proceed to the next step. The wizard will prompt you to draw the gingiva margin line. It is exactly the same margin draw mode as for the margin line of crowns and copings. Add as many points as required to design the border of your gingiva area. Finish drawing the margin line with a double click. You can still do corrections on the margin line. Add points with the left mouse button and remove points with left and the right mouse button. Apply again to recompute the changes. The gingiva design shape can be influenced using several parameters. You can change the thickness of the base, the cervical border thickness around the teeth, and smoothing of the surface. You must confirm each adjustment of parameters or margin with Apply. As you can see here, different parameters will result in a different design. But I will recompute the Gingiva with the default settings, as these give really good results. You can also use the Clear button to clear the margin and restart from scratch. When you are done, proceed to the next step. The Gingiva freeforming tool differs slightly from the known freeforming tool for crowns and bridges. The anatomical freeforming mode only provides two different options. The default small region option allows you to move smaller parts of the gingiva, whereas huge region allows you to move major areas. When moving bigger areas, bottom and boundaries are fixed by default. If you uncheck this option, the boundaries and bottom will also be moved. The desired thickness of the gingiva will be maintained only when morphing parts of the gingiva. As you can see here, a thickness of 1 millimeter will only be regenerated in the morphed area. Note that only changing this thickness value will not recompute the entire gingiva thickness. Furthermore, the thickness can be visualized with an adjustable color scale. Now, click on the Free tab to access the virtual wax knife. This tool behaves exactly the same as in the known freeforming mode, where you can add, remove, or smooth material with different brush types, adjustable in size and strength. This tool can be used for the final touches. Now proceed to the next step. In the first part of this tutorial, I already introduced two features in the shrinking dialog. Now I want to show you the Cutback Design Library feature. In this tutorial, I only want to talk about the Cutback libraries. Retentions and Thimble will be shown in a separate tutorial. There are two different Cutback libraries: facial ridges and incisal ridges. Let's start with facial ridges. These will reduce the tooth with ridges on the facial side where the incisal edge remains untouched. The incisal ridges affect the facial and incisal side. As you may remember, we have added material on tooth 16 and removed material on tooth 26 during freeforming at the beginning of this tutorial. Now you can see that the Cutback libraries are not able to adjust automatically to the shape with the added material, but the Cutback libraries will be cropped automatically where we removed material when you click Apply. Here you can see how tooth 26 is cropped. Let's compare both teeth again. For tooth 16, the free-forming changes are not applied. Tooth 26 has been cropped correctly. That's why I recommend not to use free-forming on anatomical teeth or to remove material only. Again, you can use all the known free-forming options. If you want to work with cutback libraries, the best way is just to do the tooth placement and to do fine tweaking using free-forming here in this step. Before you proceed to the next step, you can decide if you want to reduce the gingiva. This additional step is only available in expert mode. Click Shrink Gingiva Design Part in the expert frame. Then enter the desired depth of shrinking. By default, the option Auto Select Gingiva is active. This option automatically excludes the frame's lingual part and the frame's intersecting parts with the teeth from being shrunk. Let's hide a tooth to show this excluded part in the tooth area. Of course, you can deactivate this option and/or clear all brushed areas to shrink the entire gingiva if you want to brush areas manually. Remember, the brush size can be adjusted using Shift and the mouse wheel. Brush with the left mouse button and toggle the brush with Shift and the left mouse button. If you activate Auto Select Gingiva again, only the intersections between teeth and gingiva will be brushed automatically. Click Select All Around to get back to the initial default situation where the lingual part of the frame and its intersecting areas with the teeth are brushed. You can adjust the thickness of the blue border surrounding the teeth by changing the vestibular height value. There are two additional options in the Preserve Area Around Teeth dialog. Always exclude parts inside teeth means that areas inside the intersection between teeth and gingiva will never be reduced, even if they are not brushed. Preserve gingiva around teeth means that shrinking will try to avoid going inside the tooth surface, even if this area is not brushed. In this case, some teeth intersect with the basal area of the gingiva. That's the reason why this area is also brushed automatically. This can be corrected manually or can be avoided with a correct tooth placement or adaptation. As in the tooth shrinking step, the Shrink Gingiva feature also provides multi-level cutback and advanced parameters. I already explained those features earlier. Click Apply to start the gingiva shrinking process. Then click OK to close the dialog. Note that in Expert mode, you are even allowed to still change the position of the cutback teeth. This can be used to do some fine tweaking if required. But this should better be done before you shrink the gingiva, because now the gingiva design in the tooth area does not surround them anymore. Let's undo and close that step. If required, you can again freeform the gingiva right here in Expert mode, even if the gingiva has already been shrunk. Let's restart the wizard. We are now back in the free-forming dialog, which I already have explained before. Proceed to the next step, which will be the connector step. I'm sure most of you are already familiar with this step. That's why I won't explain it in detail. The connector step will be explained in a separate video tutorial. I just want to explain the two cross-section shapes that might be useful for this kind of restoration. The tooth-to-tooth connector shape joins tooth shapes directly by using the existing tooth geometry. By default, this connector shape ignores the minimum cross-section area. You can also delete all connectors. As for this virtual Waxup with Gingiva, all the teeth are connected by the Gingiva. Proceed to the next step, the creation of the virtual Waxup. Note that this step might take some time, as several operations need to be computed. When the virtual Waxup has been generated, you can click Next to proceed. In this free-forming step, you can free-form the merged restorations as usual. Smoothing and melting in areas between elements is possible too. This can also be used to adapt the whole frame to the Gingiva again, if required. Proceed to the next step, which is the screw hole design. I already explained the advantages of the screw hole design in the first part of this tutorial. This time, I will switch them off to show you the difference. Proceed to the last step. Thank you for watching this video.